If you were to imagine building a life in space, would you picture living in an expandable balloon? A team of engineers and entrepreneurs is working to make exactly that, an inflatable space habitat. These stadium-sized stations are set for a first launch as soon as 2026.
You package it tightly, you launch it to Earth orbit. Once you're in microgravity, the nose cone opens, the expandable pops out, and then it inflates.
The expandables are quite different from the more traditional rocket structures we've used so far.
You have a rocket, it has a nose cone on it, and you have to stick your payload, what you're delivering to space, you have to fit it inside.
But with an expandable habitat,
you can go to sizes that are much, vastly larger than what a rocket could launch right from Earth's surface.
This isn't the first time we've seen an expandable habitat in space. De Jong himself worked on
the only two demonstrators on orbit, Genesis 1 and 2. They came right from behind this wall here.
So what's different about this project? It's predictability, particularly in relation to pressure loads.
If you have a grocery bag and you put your celery stick sideways, it's going to pull in one direction, but not just in the one direction. You don't know if it's putting loads on the fabric a little bit this way or that way, and you don't know when your bag's going to blow out and your celery's in the parking lot. We've come up with an architecture that the pressure loads are just being carried by these essentially ropes that tie the North Pole and South Pole together. If I prove the strength and the predictability of just one of these ropes, it feeds directly into the flight qualification for the whole structure.
This architecture could come in handy for in-space research, tourism, and more.
Earth orbit is a really suitable location to test the things like pharmaceuticals, semiconductors, and so on. It's all because of the microgravity.
Not to mention,
this architecture is being looked at for long-term habitation on the moon,